So I want to talk a little bit about why we're having this panel, and I'll get right to you, Brian, on this. So, for a long time now, the Army's been talking about advanced manufacturing, and you've actually laid that out. Mr. Raftery's been around to the trade associations, had a good exchange with us, and gotten a lot of input there. There's a lot of potential, but there's a number of complicating factors that I think are useful to keep in mind. One is that we all experience the past is always stronger than the future. Right, because it's well occupied by plenty of people who believe it was as close to heaven as they can get, and they're determined to keep it that way, and we've all experienced that, right? But the future is, in fact, where we all are going to live, and so it's important for us to align with that as we go forward. There's a lot of opposition from, this is not my idea, it's not invented here. Ms. Lord mentioned the intellectual property challenges. That's true, of course, in major programs of record, but it's true in an awful lot of other areas where we engage as well. And of course, there are cybersecurity concerns that she raises, a whole bunch of issues on there. So that's why this panel is put together, to really look at what, and I'm going to introduce the panel members in turn to do that, but also the how of how we're going to do it. And lest we think we can do it alone, we invited the U.S. Congress to participate in this process, because the last time I checked, we don't get very far in the how unless they're sort of on board with us along those lines. And then, of course, finally, we rely on expertise of people who know what they're doing better than we have. And so that's really, and I think, General Ham, I want to congratulate AUSA for putting together a panel that can answer all of those questions. And if we can get all that done in, how much time do I have left? 54 minutes, roughly. Then we're going to put you back where the future is stronger than the past. So our first and our chair here, Mr. Brian Raftery. Of course, I have a nice introductory piece for him. I'm going to cut it as short as necessary, but as you mentioned, he's the Acting Deputy Assistant Secretary of the Army for Strategy and Acquisition Reform. Did they tell you that the longer the title, the more important the person?
I've only had it for about 3.5 weeks now.
But he's Principal Advisor to the Assistant Secretary of the Army for Acquisition, Logistics, and Technology, which we all think of as ASALT, responsible for design and implementation of acquisition reform, of modernization initiatives. He owns all of those little lines in Ellen Lord's trifold there, and you're going to have to do all of that as you go forward, I think, here. But he's also been Director of Acquisition Policy, spearheading two critical Army-wide policies: advanced manufacturing, intellectual property. They come together all of course here. So I'll turn my microphone off, and you can turn yours on. Yours is probably on all the time.
Okay, thank you. Good afternoon. Thanks for inviting my boss and getting me. As I alluded to earlier, I've had the job for about 3.5 weeks now. I was sitting in an establishment in Highland Falls, New York, where cadets are allowed to have stuff with my son. I get a call saying, Dr. Ross needs to talk to you. And she goes, I can wait till Tuesday. And I'm glad I did, because it would have ruined a perfectly good Army VMI beatdown that happened the next day. Advanced manufacturing, is a very visceral topic for me. I've had basically two jobs in my life. One is working for the Army, both as a uniformed officer, and the other as a civilian. And before that, I worked for a little place in Massachusetts called the Duxbury Fix-It Shop that was started by my grandfather. And I started there in about full-time almost when I was not at school in about 1979. And we sold and serviced outdoor power equipment, and the preponderance of everything that we sold and serviced was made in the United States, and the tools that I bought, that I used were made in the United States. If you went to Sears and bought a ratchet, you get a Craftsman ratchet that was made in the United States. You went to Ace Hardware, you went to True Value, the stuff that you bought was made in the United States. You went to Home Depot, went to Lowe's to get tools, stuff's made in the United States. Well, if you go to any of those places now, the stuff is probably going to be made in China. The only way you're going to get a hand tool made in the United States is if you go to someone like Snap-on or Matco, and right now the top of the line tool set that they make is on the order of $55,000 for a Snap-on. So the Snap-on tools are about order of magnitude more expensive than the stuff you get at Harbor Freight or Sears, which is all made in China. And so it was my surprise when I went to Lowe's about a year ago, and I saw this half-inch impact wrench that put out 1,200 foot-pounds of torque. And I'm like, I got to get some of that. You can take off a tank lug nut with an impact wrench like that. And the best thing about it was It was made in the United States, and it was made. It was on a price and quality same level as some of the Chinese stuff that you see at Harbor Freight. But the way that DeWalt was able to do that, and if you go to MXD out in Chicago, you'll see a laydown of some of the factory floor processes that DeWalt uses. They're using advanced manufacturing, and that's how they stay price and quality competitive with what the Chinese put out. And it was my great joy that I found out that Sears sold off their Craftsman brand to Stanley a couple of years ago because it had some value, but the tools were made in China. And last summer there was an announcement that Stanley Black & Decker was opening up a state-of-the-art manufacturing facility in I think somewhere in the Dallas area to manufacture hand tools in the United States again. And again, to do that, they're using advanced manufacturing. So when we put this policy together, it's been in the works for over a year. It was very much informed by what we consider, the state of the art and the state of the industry, which are moving along quite well. And as we started to get our minds around where the policy should go, the focus had always been on additive manufacturing for readiness, which is a noble cause. But as we started to research and dig down into the subject matter, really what you're doing when you just want to 3D print parts is you're going to end up reverse engineering an entire vehicle or whatever the platform is. And that may never get to be cost effective unless you have something that is just so necessary that you have to pursue it that way. And so our thought was, if we can infuse these processes in up front and get the manufacturing done as part of the overall acquisition process, that we could not only achieve our long-term readiness goals, but also have advanced capabilities in the very near term, because there are things that are simply far more possible and practical when you use advanced techniques than you use some of the legacy techniques. So before we get into the panel, we want to just share some things on what we, the Army, think advanced manufacturing means to us, why we're pursuing it now, and what the new policy does. We consider advanced manufacturing really to be a fusion of new modern techniques and materials, along with some traditional techniques. It's broader than additive, pure additive, but it includes it. It also includes robotics, artificial intelligence, and composite materials. My boss took a trip, or my former boss, Dr. Ross, took a trip to GE Aviation a couple of months ago and came back kind of wide-eyed when she saw what they were doing. And in fact, some of the work that they'd been doing had really shaped where we are going thought-wise. You can make a heat exchanger using 3D printing that replaces the skills of a Swiss watchmaker, and also eliminate failure points, get rid of weight, reduce cost, and only have to make it one time. Whereas with the old techniques are far more complicated, have additional failure points. And so it was kind of eye-opening, when she came back, and then she used that example. Similarly, if you look at what's going into some of our new helicopter engines right now, they're already including advanced techniques with fusion of metals and ceramics into a single material, using techniques that are cost-effective now that enable power gains, weight savings, and increased fuel economy that were unachievable using legacy techniques. And the other question is, why now? The reason now is we're really in a catch-up mode. And I think some of the things that Ms. Lord articulated were particularly apropos and timely for what we're going to talk about both in this panel and the next one on intellectual property. We're trying to, in a lot of cases, catch up with adversaries. China is making huge investments in future manufacturing technologies and capabilities. I think about 2 weeks ago, there was a Wall Street Journal article indicating that they were spending $21 billion on advanced manufacturing to bolster that industry. And they're also, one of the things they were doing, I think this was in a A.T. Kearney report, They're putting 3D printers in, every one of their elementary schools. That's 400,000 printers, so that these students, get their minds around these techniques while they're in grade school. And right now, the Army and some of the other services are just now starting to field these at a tactical level. And so we wanted to push the service in some regard to catch up, but also using the skills of our workforces to leap ahead. The two areas that we really focus on, and they're in concert with the Secretary's priorities, are modernization and sustainment, as I alluded to earlier. If we can introduce advanced manufacturing, especially as it helps enable digital engineering, which we believe that the advanced manufacturing policy fully embraces, we can achieve performance enhancements and increases faster and more economically than we've ever been able to do that in the past. No longer is a complex custom component taboo when it comes to producibility or manufacturability. It's something that you can achieve economically and increase system performance. And the other hand in hand with that is sustainment. Obviously, we want to reduce sustainment costs, and I think part of the real promise is if we can design out obsolescence by having what I call a perpetual hot line that you turn it off when you don't need it and it's back on the moment that you need it. If we can achieve the investment opportunities of avoiding just-in-case procurement of spares and invest that instead in capability, knowing that we have the ability to realize the 1980s and 90s dream of what they call just-in-time that never really worked. That might offer some promise for the future. Things like on-demand production close to the point of need. Now, in a lot of cases, some of your more intricate components require certain facilities that are not going to be available on on a fob. But there are opportunities to increase readiness, reduce times to get parts to the point of need, and overall increase readiness at a reduced cost. With that, our policy is driven by three overarching principles. We need to make strategic investment by Army and industry, and what we're not saying is pour money on the problem. Part of what we want to do is we want to shape industry response to help us influence our investments. We've already made a modest investment in the Center of Excellence out at Rock Island, the Advanced Manufacturing Center of Excellence, to get us in the mindset and with the capability set to perform these tasks. The other key is we want systemic adoption throughout the life cycle. We want the entire life cycle to be to utilize these techniques. It would apply to we want it to apply to new systems with the understanding that if you design it in up front, when it comes to sustainment, you've already built in the opportunity to take advantage of those techniques. It also, if you test your designs and systems as a system when they're first introduced, you don't have to requalify something, which is a huge cost, especially when it comes to like aviation systems. When you replace something that you can't get anymore, it still has to go through the configuration management process. It's not magic. It can be costly, so we want to try to avoid that as much as possible. And the next is, it's not a panacea. We want to encourage deliberate and thoughtful use of these techniques. One of the things that we were reluctant to do at first was to encourage or tell material developers that they need to consider this, and we ended up putting that in the policy, not to tell them that they have to do this, but it should be considered, and we still leave it up to the discretion of, individual program officers to make that best value decision for whatever the system is that's in question. But we do want it considered. One of the other challenges is, the return on investment. There's going to be some cases where, you're not going to get an immediate, 10-to-1 return on a dollar invested. Some of these may be longer term strategic investments, and we understood that. And the other consideration, and we're going to talk about this later, is intellectual property. We believe that the principles of our intellectual property policy, which we'll talk about later, are somewhat universal in nature and don't, conflict with advanced manufacturing. We've had, as Mr. Berteau indicated, we've had numerous industry engagements. So before the policy went final, we were able to engage a number of the trade associations to get their feedback, so that we weren't, causing a perturbation in the force. And part of that was, some of the things we talked about were new and innovative, license models, pay to print or pay to produce kind of things. And the sense that I've gotten so far is that, they're very open to that. And, as part of our IP policy, we're not going to be, scanning somebody else's proprietary item and then go printing it and hoping to, to get that for free. That's not at all what we're thinking. But we're looking for new and different ways to do business. And with that, I think that closes out my introduction, and I will turn it over to the panel.
All right, thank you, sir. Takes me 3 times to actually get it right, but I'm getting a little closer to getting it right each time here. Press button, then talk. Got it. Thank you, Mr. Raftery. I appreciate that. The Army has a long history of good ideas at headquarters that eventually have to be executed and implemented by somebody who's not in headquarters. And I think the panel here has a good representative of that to start out with. Major General David Bassett. I don't know, sir, if you think you're representing that, which is not headquarters, but that's kind of the way I look at it going forward, because you got to take what Mr. Raftery just laid out in terms of what the plan is and turn it into something. So General Bassett is the PEO for Command Control Communications Tactical, based out of Aberdeen Proving Ground. Moved there some time ago from a different state, which was another good idea that came out of headquarters, which we won't go back to. This is on the record, isn't it? I better be careful how far I go. As PEO, he guides a workforce of more than 1,600 personnel who acquire, field, and support tactical communications network. And his previous assignments, of course, include PEO for ground combat systems, where he was responsible for combat vehicle modernization efforts. So, General Bassett, the floor and the microphone are yours.
Thank you very much, and appreciate the opportunity to participate in the panel today and to talk about a topic, obviously, it gets an awful lot of attention. I really appreciate the introduction by Mr. Raftery, because now I can blame higher headquarters for all of the policies, right? So we've gotten that out of the way already. But I really do appreciate it, and I think the dialogue on advanced manufacturing has gone in a really good direction, because when this first started out, I would say that advanced manufacturing had been conflated with forward manufacturing and only with additive manufacturing. And so the dialogue kind of went like this. They said, can you imagine how great it would be if we could just not have any parts in the logistics system, only raw materials, and we would just print the part at the point of need, right? That was the vision, right? And that had become synonymous with advanced manufacturing. And I think what you heard today is a much more nuanced, much more well-developed sense that where we really need to go as an Army, and as we apply these principles to our manufacturing base, this is a whole lot more than, say, what I would describe as forward manufacturing, right? It includes that, but it's certainly not limited to that. And so you mentioned I had another job. I wasn't quite following the logic that about the state of Michigan being some weird, I didn't get that. Loved Michigan. Very glad they lost in basketball last night. Sorry. But But I remember a time, and I'm not going to give the specific company, but in my job as the PO for Ground Combat Systems, I had an opportunity to be in a lot of manufacturing plants, both government-owned and commercial plants. And I remember one particular plant visit where I got to visit with a company that was making commercial items in one part of the plant. And in the other part of the plant, they were making some parts and some things just for me. And on the commercial side, it was highly advanced, it was automated, it was unbelievable the efficiency that I saw there, right? It was most of it being done with very little touch. There were robotics involved, there was automation. It was astounding to see how efficient they could be making this part. And I'm not gonna, it's a complex part, I'll just say. And then I went over to the military side. And it was as if I had gone back in time 50 years. Everything was being built sort of in the same station. There was an unbelievable amount of touch labor. It looked like I was almost in a different century from the commercial side of the plant to the military side of the plant. And if there's one takeaway I hope we get from advanced manufacturing, is that the time has come for defense manufacturing in this country to modernize. There are techniques and materials and processes available to us in the digital world that should make us significantly more efficient, even at relatively low volumes of production. And so at the time, the excuse was always the same. We could automate, we could give you robotic welding, we could give you all these other capabilities, but we can't close the business case because you're going to be so erratic in your demand and so limited in your quantities that I can never pay for the tooling and the machinery. And we're hoping that with the introduction of these new advanced manufacturing techniques, which does include but is not limited to 3D printing, that we can now begin to bring to bear those technologies on defense manufacturing. And so what it implies is, I think, a modernization of both the manufacturing and the design base in a way that should change our processes overall. I think that process starts with a shift towards start to finish digital engineering, where we're able to not just, we're not just talking about CAD drawings anymore. We're talking about the ability to put those CAD drawings into models, to understand manufacturability, and then feed those digital engineering outputs into advanced manufacturing techniques. And so digital engineering, a big part of that. Now, Ms. Lord talked about the threat of exfiltration of our defense data. And I will only mention that if we are serious about digital engineering, we should be serious about the cyber protection of that digital engineering data. And it's one thing to have someone take a picture of one of our advanced capabilities. It's another thing for them to have a digital design document which tells them exactly how to build it. And so I do get nervous that we can't just rush into this future without making sure that we're kind of locking the gates on protecting the nation's intellectual property for these advanced military capabilities. It takes us a long time to develop advanced technology, and it can be stolen from us in an instant. And we do not want to enable our adversaries to replicate the kinds of investments that we've made over many years and many dollars without having to make those same investments and invest the same in people. So just a caution that says, yes, digital engineering, yes, digital engineering that's appropriately cyber protected, and I'll use that as an element of my current position. I think it's incredibly important. So it starts with digital engineering and it ends with manufacturing, with techniques that are now available to us that should aid in efficiency and allow us to build things we never could have envisioned. This is a whole lot different than this suggestion that we're just going to print all of our repair parts forward. This is, I think, something that looks across the entire life cycle, starting with design, manufacturing, and sustainment. It doesn't end with manufacturing. And so if you've started to build a system this way, when you get to sustainment, you should be able to identify what are those subsets of parts that you can manufacture in different ways, particularly if you have, say, diminishing sources of supply or a limited supply capability that needs to be shifted off to do something else. And so, we talk about just-in-time sustainment parts, and we still have that dream. But I think part of just-in-time is I want to be able to qualify it at a certain point, be confident that I can make it, conduct something analogous to a first article test, and then be able to sort of turn away, do other things on that line with that machinery, and then turn it back on without requalifying those parts. And so when we think about the set of parts that we're going to be able to do with that, it's not going to be all of our repair parts. I mean, we're not kidding ourselves into thinking we're going to 3D print every tire on the battlefield. We're not kidding ourselves into thinking we're going to be doing, structural metal parts necessarily. We're going to have to look really carefully to say what other parts I can do that with, and then how can I apply the entire range of advanced manufacturing techniques in a way that's practical and sensible, and then we have to make this real, right? We have to turn potential and promise into real products that our soldiers can use on the battlefield. And that's not going to be a leap to the future where 100% of what you need to deliver is going to be printed on the battlefield, but it's about identifying what the subset is that you can build into your systems and make sure that when you get to that point of sustainment, that those options are available to you. We have already seen in the benefits of 3D printing technology and advanced manufacturing in shortening the time it takes to build prototypes and to deliver initial capability. So when we were putting the trophy system on the Abrams tank, the first brackets that we used to fit up those systems onto the Abrams tank were 3D printed in a government lab. Right? They didn't have to be structural. We could pull them out of plastic, we could get the size right, we could get all the holes in the right place, and we could shorten the timeline to delivering those capabilities. And when the time came to actually manufacture, we didn't 3D print them. Right? We used traditional manufacturing techniques because they were structural, and we could do it at a cost that made sense. And so I think when we think about advanced manufacturing, we still have to be open to the idea that it's going to take some hybrid techniques between advanced manufacturing and traditional techniques that take into account cost in a business case, right? Could I have printed them? Probably, but it wouldn't have made it a good idea. So, all right, well, with that, I don't want to take up all the time. I'm going to turn it back to you, sir.
All right, third time's the charm. It is always a good idea to leave a little bit of time for Congress. Because no matter how good the idea is, and no matter how good the implementation execution plan is, the U.S. Congress has got a say in it. And there's really nobody better to reflect both the approach and the necessary questions that come into play than Dr. Arun Seraphin. He and I have worked together a long time. He's been in and out of both the executive and the legislative branches, and he's been working technology, acquisition, manufacturing policy issues on the Hill since the machine tools were not in a museum, but were actually live and on the shop floor for more than 2 decades now. He's also been in DARPA as well. He's currently on the staff of the Senate Armed Services Committee, working for Senator Jack Reed. And Arun, I know from personal experience that you not only are a hard gate to go through, you ask the hard questions that actually need to be answered in order to get through the gate. So how does Congress look at this, and in particular, how do you look at this idea?
Well, thank you, Dave. Thank you, AUSA, for the opportunity here. I need to give my standard disclaimer, which is I'm not speaking for Congress. Turns out I'm not Congress. I'm not even Senator Jack Reed. The views I give here are not the views of any of my current or past employers or future employers. Some of them are not even my views. I'm just floating them to see what the reaction is. So with that, I'll say the basic answer is the Hill is very supportive of advanced manufacturing and its ability to improve the industrial base. And it's pretty easy to see why, because I think in a member's head, it turns into local jobs, it turns into economic development, it turns into national security capability, things that my bosses really do want to see move forward. Manufacturing is very local, and I work in a place where place still matters, where things are done is very important to my bosses. And it turns out, having been at my 97th AI meeting this morning, it's a lot easier to understand than a lot of the things that my bosses have to deal with. Manufacturing is something that people just get from a long-standing tradition of manufacturing locally and in support of defense. So I think we're going to be supportive, and I think the track record is, both on the legislative policy side and on the funding side, we have been supportive of manufacturing initiatives. So if we are in an era where we're going to, the department is going to claim to push more advanced manufacturing initiatives, then I guess what are the kinds of things that I would look for to sort of take it seriously, as opposed to the last 3 or 4 times I've heard that we are taking advanced manufacturing seriously? I guess number one, of course, is resources, right? So we have on the RDT side, RDT&E side of the house, programs called manufacturing, right? There's a ManTech program. There are manufacturing institutes being funded. There are tiny bits of manufacturing science that are funded out of DoD. In some ways, they're programs that we sort of fund to a level to say that we're doing them, but not to a level to actually get anything real done. And so if we're going to be serious about advanced manufacturing like some of our competitors, there's a level of commitment and resources that shows that degree of seriousness. Going back about 15, 12 years, something like that, there was a Defense Science Board study on manufacturing. They recommended, I mean, it's easy for them to recommend spending more money, but they recommended, okay, a benchmark might be 1% of the RDT&E budget spent on manufacturing technology. So, you know, in a $100 billion R&D budget, that's a significant amount of money, right? So, and we've never achieved that. So, resources on the R&D side demonstrate some seriousness on advanced manufacturing. But I think the other thing that we haven't really embraced is the idea that R&D dollars are good at promoting innovation, but procurement dollars are also good at promoting innovation. And if we spent our procurement dollars in a much more tactical way, but with some strategic thought to address shortfalls in the industrial base or to encourage the use of advanced manufacturing technologies, I think we could shore up those industrial bases that we really want shored up, whether they be domestic or in partners or wherever. But the idea that the government procurement dollar could be a way to send market signals, to create initial markets, to shore up failing or growing industrial sectors, I think is something that we haven't really embraced. And I think any conversation on advanced manufacturing needs to be coupled with this sort of idea that procurement industrial policy is something that the government is going to embrace. It turns out that our large competitors, one of the reasons we are so wary of our large competitors, is they have a very robust industrial policy. And their government and industry efforts at promoting manufacturing are sort of indistinguishable one from the other, right? So why is it that we shy away from the equivalent levels of industrial policy, even in the small sector of using government procurement dollars to promote whichever sector of manufacturing we want to promote, domestic manufacturing, for example? If it looks like DoD is taking this seriously, one of our signals is general officers, SESs, honorables who come and testify, talk about it a lot. It's not just in the written testimony, it's actually said out loud occasionally. And truthfully, that hasn't happened very much yet. But that fighting its way into the talking points of the chief and the secretary would be a good signal that something real is happening. Travel is a big signal. We track, Austin's a wonderful place, but does everybody have to go to Austin? Right, Silicon Valley is a wonderful place, but does everybody have to go to Silicon Valley? There's lots of interesting manufacturing going on in other places in the country. I don't know that I see a lot of senior officials from DoD taking those kinds of trips. It's great to hear that Ms. Ross took some of these kinds of trips, but those kinds of signals indicate to us that, okay, you're investing your time in front of Congress and you're investing your own time to see what's going on and to try to make changes in the industrial base, as fun as it is to go to Austin and Silicon Valley. Again. So, and then I think the telling of the story in a way that makes sense to whichever audience you happen to be in front of at that moment, right? So there's certain audiences where you're going to have to talk about the operational capability that results from the advanced manufacturing capability. And then when you're in front of those kinds of people, like my boss, for example, you have to tell the story that way. When you're talking about advanced AI used to support manufacturing process lines, like if you're talking to me, right? So it's a different kind of story, right? Or if it's and the Navy is particularly good at this. our Mantech investments resulted in these kinds of life cycle cost savings, right? And that's the different. My friends in the Appropriations Committee want to hear those kinds of stories, right? So that sort of differentiated communication, differentiated education, for things we take seriously, DoD is pretty good at that. For things we don't take seriously, it's sort of varied or the same talking point over and over again. I think we'd like to see that manufacturing fights its way into our traditional partnerships. And so I would sort of look at the institutions that we trigger off of. In this case, what's the role of the depots in the adoption of advanced manufacturing? The Centers of Excellence idea is honestly something we pushed a little bit from the Hill, and it's great to see Rock Island sort of embracing that, but what a great place to try out new technologies. It's a safer place to try out new technologies. It's a safer place to establish joint ventures with the commercial sector, and it makes members really happy to work with your depots and your shipyards and your arsenals and things like that. I honestly haven't seen a lot of the use of the depots as the place to do that kind of experimentation, to do that sort of DT, OT of new technologies to get through these qualification issues on 3D printed parts, for example, right? What's the role of the labs and the RDEX in an advanced manufacturing initiative? There's a huge amount of technical expertise there. It's the expertise that's most intimate both with advanced technology and Army military missions. There's no other group that's quite that good. And so there's no other group, I would argue, that could best position advanced manufacturing technologies to support Army systems into the future. I don't quite know what the role yet is of RDEX and labs in a broad advanced manufacturing initiatives. And similarly, some of the programs that we sort of take for granted also could have a role. University research initiatives. There are things, the manufacturing science is a thing. It's some elements of material science. These days it's a lot of data science. It's a lot of systems engineering. It's also our source of future talent. Future talent that could work at the RDEX, future talent that could be the customer in the Army who understands good and bad manufacturing, right? So how do we engage with the universities to do that cutting edge research, but also create that workforce pipeline to come and work in the Army and the services in general? And the small business community, I think, traditionally gets left out of major initiatives like this. DoD sits on an annual $1.3 billion SBIR budget. It's a great program. I've got no complaints about the program, except that it sort of exists off by itself outside of all of these large initiatives. I would think that if you're trying to target and strengthen lower tier, smaller scale manufacturers and imbue them with some advanced technology, a more strategic, organized use of the Army's SBIR program would be a good way of going at it, right? And so I don't know if SBIR is good or bad for this purpose. I do know a couple of things going for SBIR. It's going to be $1.3 billion roughly a year. Not even the appropriators can say something about that. That's pretty good. Nobody understands what color of money it is, so you can pretty much spend it on what you want. And it gives you this incredible advantage in terms of style of intellectual property arrangement and contracting arrangement, which allows you to pull things, in theory, more rapidly through the system. So I think SBIR is a good tool to potentially use to promote these advanced manufacturing initiatives. And then the final thing I'll say is we'll take manufacturing and we'll see that people take manufacturing seriously if the community that develops strategies and the community that does wargaming also acknowledges that manufacturing is a thing, right? So I have a nice collection of strategies that I've collected over the years. They often postulate a future force, right? I found my Joint Vision 2020 the other day. But they assume that that future force is magically producible and manufacturable on demand, right? The war games that I don't get to go to a lot, but you get to experience them, they also sort of assume a manufacturing industrial base, right? I guess it would be interesting to speculate, like, okay, there's a hot war in a place like the Pacific on day one. On day two, markets have all crashed, all shipping has stopped. So people have stopped going to work because it turns out there was a war on day one. Okay, so now how are you still producing anything and delivering it to anyone, right? So I've yet to see anyone sort of take into account what happened on day two to the industrial base. into the shipping or whatever, those kinds of things, especially in a world where we're so dependent on a commercial industrial base. So if there really is some serious level of effort on taking manufacturing and imbuing it in across what DoD is trying to do to modernize, I mean, those are the kinds of things I would be looking for going forward.
All right, thank you, Dr. Seraphin. General Ham, I would suggest that a topic for next year's conference would be exactly looking at how these ideas actually do get folded into how we exercise and how our plans turn into that, because we all know that we tend to assume away all the problems in the games, the problems in the back of the world, that we say, well, that'll take care of itself. We just need to see how the forces play out. So that might be something worth looking at. Typically, the way the moderator runs the panel is he goes through all the speakers before he asks any questions. But since we've got only 15 minutes left, I'm going to give a homework assignment question to a couple of the speakers who's already gone to give you guys time to think about it, even though I know you want to listen to what Mr. Staub has to say. Give you guys time to think about it. Arun's already raised one, which is how do we get advanced manufacturing into the maintenance depots? In fact, General Bassett, when you were describing the factory there, I thought you were talking about a couple of the depots that I've been to as well. So we have a little ways to go on that. And the second one, particularly for Mr. Raftery, Arun also mentioned the budget. And, you know, the adversary that we've talked about here does not have a 3-year budget cycle. When a new idea comes in and they steal it, and they can be working on it in 3 days. How do we change the way we do our budget cycle, particularly inside the Secretariat and in the Army POM, to be able to accommodate what you're doing? So those are homeworks. You don't have to answer those questions yet. We'll come back to those in a little bit. And with that, I want to turn. So no panel is complete unless there's actually somebody in the panel who knows what the heck they're talking about, right? So we're all users of this, right? None of us are actually capable of designing and developing these new techniques and implementing them on our own. So we're grateful enough to have with us here today a real expert. Jeffrey Staub is a partner in A.T. Kearney. He's in the practice that focuses on aerospace and defense. So he's also the director of A.T. Kearney's Manufacturing Center of Excellence for the Americas. So he's got a good government side of the background there, but he's also got a commercial industry side of the background. In fact, he actually, he was a plant manager for a Tier 1 automotive aerospace and off-highway supplier that was having to go through this process themselves, perhaps longer ago than Rock Island did. So with that, I want to turn the microphone over. I know we have 14 minutes left. Over to you, Mr. Staub.
Yes, I'll be pretty brief here so we can get to the Q&A. Thank you for the introduction. Thank you for the opportunity to speak today. I'll do my best to riff a little bit on what I've already heard, but also introduce some of those more interesting topics of really how is this being adopted in the commercial sector. I think General Bassett used a great term, nuance. When I listen to the principles described by Mr. Raftery, have conversations with Admiral Selby or General McMurray in the Navy and Air Force, even with Dr. Ross before she transitioned, I think the principles described there are generally correct. I think the challenge is when you get into the nuance, and this is not necessarily a policy that can be deployed with principles like small business set-asides or core versus commercial industrial base or other things that are a little bit more black and white. This is one that requires quite a bit of understanding of the nuance of each situation, and I like to say just descending into the particulars. When you think about additive manufacturing, most people would say that it's really 8 distinct technologies. And when you think about additive, the difference between putting a prototype bracket on a Abrams tank versus putting a metal component into the hot section of a F-135 engine versus printing organic material for bandages in the battlefield versus printing barracks for people in the field. They are widely different applications, need to be thought about uniquely, and that doesn't even get us to augmented reality, advanced robotics, and all the other applications that we think of when we think about the future of production and IoT, or Industry 4.0, excuse me. So I guess what I would just emphasize when I think about how to incorporate the policy and some of the items that General Bassett was talking about, I can confidently say I spent a lot of time in that shop as well, It is not in Silicon Valley or Austin, so it is one of those areas that we can really focus on and develop is what problem are we trying to solve when we go and deploy advanced manufacturing. We can't look at it from a technology for technology's sake. I think it's very easy to get excited by the vision, the aspirational aspects of additive or advanced manufacturing. But I think when you get into what is the business problem or mission problem that we're trying to solve, how will this actually help us achieve it? That's when it gets really interesting in my mind. And I think trying to even define the value proposition of additive when you say, what is the value proposition of being able to print something for a downed vehicle in the field? How do you put that into a business case? How do I think about 15 years the supplier going out of business and not having to deal with obsolescence? How do I value concurrent design when I can change parts without buying an extra $500,000 of tooling every time I need to change something? So I think one thing we really need to focus on is a use case approach. And all I mean by use case driven is when you look at a portfolio of products, looking very specifically about what those advanced technology applications can solve and how do we actually deploy them on a specific application. And what I believe is when you get into the nuances, the particulars of that case, it does start to lay out a template to follow. When we put a valve, when the Navy put a valve body on the USS Grant, we were talking to the head of AM for NAVSEA. The first thing he said, he was embarrassed by how long it took to get the part approved. It's easy to get mired down into an 18, 24-month process because we don't know how these materials are going to evolve in time. They need to be tested. You get into shock and vibe, and you hit a brick wall. So how do we make that process faster? And I think those, because each of the applications are different, you need those use cases to provide those roadmaps. You build up that muscle memory of different applications for different technologies, and I think you have to go in a use case approach to solve a particular problem. And I think it's really important when we talk about additive and other pieces specific to make versus buy. Where do you want this technology to sit? Do you want it to sit in a depot? Do you want it to sit at an OEM where you have kind of a much closer alignment to the product that it's going on? So I think that's kind of where my thoughts were around incorporating into policy into reality. When I think about the industrial base side, I've had the privilege of visiting over 150 DoD sites for GCS. We got to go to 72 sites in 12 weeks. That was a very exciting whirlwind. And we continued to kind of apply manufacturing improvement opportunities across almost every major defense platform. And I think when we get into those programs, it's very clearly a short-term focus. How do I make the business case work in the contracting timeframe and not necessarily the long-term view? And when I think about the value proposition that we talk about, rapid prototyping, obsolescence management, consolidating the number of components from 20 to 1, eliminating layers of the value chain in the production cycle, what does that mean? It's about 6 different contracting actions. So when you look at the business case, it's very hard to make it sing unless you have that total life cycle view. And I think that's where funding and investment can really take away some of those constraints of how we think about things today. I do think it's incredibly important to stay very close to the industrial base. I think when I look at the capability required, the best companies in the world are struggling with capability. It is one of the things that really is holding back folks. When you look at the history of industrial revolutions, this is typically called the 4th industrial revolution. It's about useful knowledge and how people are able to utilize and tinker with those applications and advances in technology. And most people would say that it takes time. You need those use cases to really get people thinking, how do I deploy? How do I think about performance for design versus performance for manufacturability? And how do I unlock that value proposition? And I'll just close out by saying, what do I see in the commercial sector of what makes companies successful? I'll go back and repeat myself. I think it's about focusing on what problem you're trying to solve. I'll use an additive for an example. Additive solves a performance problem. It typically is not a cost benefit unless you're really taking a ton of material out and lightweighting something, or you're thinking about the full life cycle, like fuel consumption, how that changes the overall cost of a product. So when I look at what actually works well is that taking that end-to-end view. I think when you have a siloed point of view, when I think about Army, Navy, and Air Force working independently, OEMs working independently, protecting the advances they're making because it is a differentiator, how do we unlock some of that connective tissue across those investments to get the best for the DoD across the board is going to be really critical. The second piece I'll just talk to very briefly is cannibalization. You have to take advantage of the products you already have, the products you already know, and really look to say, what does an AM or a advanced manufacturing solution look like for something I know how to make today? That gives you that muscle memory, the use case, the opportunities to flex those advanced manufacturing muscles. And what I would recommend focusing on, and what I've seen commercial focus on, is you have a obsolescence problem today with a component on an engine. You don't think about that problem. You think about the family of products across the DoD that have components like that, and you think about how can I solve that problem. It's probably not going to make sense to additively print that part from a cost perspective, but when I think about how that could qualify a family of parts for the next generation of engine that's being produced next, the current production, as well as the obsolete part, then you start to get a lot of momentum on how you can actually deploy this in a cost-effective way that actually brings a return on investment. And then finally, I think when you think about day two, when you kind of go back to all the unknowns, the nuances, the things that are hard to put a value proposition on, I think you do have to have some vision. And I think the danger is you go too far and say, I just want to print everything on demand. I think you have to have a practical view of what do we really want to achieve at the end of the day? Is it availability of aircraft, elimination of obsolescence, shorten prototyping, and how quickly we can field the next generation fighter? Those are the things that you want to really put a mission statement on and use advanced manufacturing to unlock.
That was very well done in a short period of time. You talked about the economic advantage of that. So if you go back to the end of the Cold War, the Navy had an aircraft that DLA worked for me at the time, and we bought the life supply of spare parts for that aircraft. In some cases, 26 years worth of spare parts. And it was a big number. I'm not going to tell you what the number of dollars were because I actually don't know how to translate it into 2019 money. 4 years later, the Cold War ended, and the Navy decided to retire the aircraft. So we had 22 years worth left of spare parts that we didn't need. That's a lot of money that had we not had to stockpile those spare parts, we could have. Now, I don't know when the next end of something is coming that's going to change everything we do. If I could predict that, this is not what I'd be doing for a living, but I think that's one of the real advantages. So I'm going to turn now, we got a very short period of time yet, to my questions to Mr. Raftery and General Bassett. So how do we get advanced manufacturing in the depots, and how do we deal with this inside the budget cycle? Whoever wants to go first.
I guess I'll swing at it. I think it starts, as Mr. Staub talked about, with a set of use cases and identifying specific parts that are consumed by the depot during an overhaul or a recapitalization process that lend themselves to that kind of process. I think in particular, we've been talking about the ability to add material to worn parts, to be able to regenerate those parts at significantly lower cost than the cost of a new part. And we did some of that, frankly, during the Stryker rebuild stuff that we were doing, looking for opportunities where you get a really good business case right off the bat. It's that longer term view where it gets a little more challenging. You're only going to achieve savings at the depot at the work you do at the depot. And so you either have to very effectively project what investments would facilitate that, or whether you'd be able to then add workload to the depots based on the tooling or manufacturing capabilities that you've added. We don't want to be in a position where we buy a really advanced piece of machinery and then it sits. And I'm not saying that's ever happened, because there's reporters here in the audience, and so I will not give you a specific example, but I can point to times when we bought some advanced machine, we thought we had a use case for it, and then we just didn't utilize it for whatever reason. So we have to, I think, guard against that as we make those investments.
And the budget cycle?
I'd like to go back to a point that Dr. Seraphin made with the SIBR initiatives. I mean, there are funds out there like Mantech and SIBR. I don't know that, there'd be anything, you're going to be able to execute anything within a year of execution to resource this stuff, except for, areas where the resources already exist. So it may, initially, until we have a longer term, strategic view, it may come down to prioritizing the resources that are already there to be used for like Mantech or SIBR or areas like that we could turn on rather quickly, as opposed to waiting for a 2-year POM outcome, depending on how successful or unsuccessful you are.
That makes a lot of sense, and it might even be useful to try to put out a little guidance to help encourage that. It's an interesting position to be sitting at a table where the people to your right are also on the screen behind you looking at you, which is the situation we're in here. I think we have 55 seconds left for questions from the floor, but I'd also note, I believe that there's a break coming after that, so it's a good time to buttonhole the panelists and ask them some questions. There's only one way out, and so you all are between us and the door, so it'd be a good time to do that. So with that, sir, you want me to yield back the balance of my time, or shall we take a question or two? I can see the clock, he can't, so he doesn't really know how much time there is. If we have answered all your questions, then our job here is done. So, gentlemen, I would ask the audience to please join me in a round of applause, thanking you all for that.